Good afternoon or morning. I hope everyone is doing well when they start watching this video. We're going to be learning about some conversions with moles now. We've been doing a lot with conversions lately, and we've even have introduced moles and what the idea of a mole is, but now we're going to work through it with some conversions. So I just have one question for today actually, but how can we convert from grams to moles or moles to grams? So we may not know what the exact numbers are, but we can always use a conversion factor. So anytime we are trying to go from one thing to another, all we need is a conversion factor, but we just need to find which one that is. So we'll talk through how to do that later, but as anytime we are converting, all we need is a conversion factor. Our objectives, we want to be able to, by the end of this lecture, we want to be able to understand the difference between molar mass and atomic weight. We want to be able to calculate basic molar masses of elements and molecules, and we want to be able to convert basic problems using molar mass. So I have a great video. Please go watch this video. It's super helpful. It made a lot of sense to me listening to it and helped me kind of think about how to teach this to you guys. So please go do that. Before we get into the weeds, as people like to say, I want to do a little bit of review. What is our atomic weight? We've learned earlier, I think in Partial 1, that our total weight of an atom, the atomic weight is the total weight of an atom. And we can also find it by adding the weight of, or the number of protons and the weight or number of neutrons. So, how is it measured? We measure it in what are called atomic mass units, or AMU units. And then to find this number, we just use our periodic table, and it should be under each symbol's name is where our weight of the atom is. So, we are going to talk about how that relates to molar mass now. So, we're still trying to find this conversion factor. We don't know what it is yet, but we have a conversion factor known as the molar mass. And this molar mass is the mass of 1 mole of a substance the mass in grams per 1 mole. So, the units are grams per mole. And our conversion factor, it's our conversion factor between moles and grams. So this is how we can get from a mole, which we've learned about is just a really large unit, to grams, which we can measure on a scale. And this is always, our molar mass is equal to our atomic weight. And the only difference between the two is that one is in grams per mole and the other is in atomic mass units. So for example, what is carbon's molar mass? It is 12.0107 grams per mole, and we got that from just up here, this unit that we would find on our periodic table, and we took the atomic weight, but put a different unit on it and called it molar mass. So, let's work through some of these together. What is the molar mass of nitrogen? So we have our periodic table over here, nitrogen. Where is our molar mass? It would be 14.007 grams per mole. Let's do another one, bromine now. So Br is right here, and our number, our atomic weight, or our molar mass, is 79.9 grams per mole. Let's do one more, molar mass of indium. Indium's right here, and our molar mass is 114.82 grams per mole. So we can now do these with compounds, though. So our molar mass within compounds is a very simple thing we can calculate. So we can find them by simply breaking up each atom and adding them together. So, for example, what's the molar mass of sodium chloride or table salt, NaCl? We're going to take the molar mass of sodium and add it to the molar mass of chloride. So, to do that, all we would do is 22.99, which we get from our sodium grams per mole, plus 53.49 grams per mole. And that would give us 58.4 grams per mole. So the compound or molecule sodium chloride has a molar mass of 58. Let's do another one. Let's do the molar mass of water, H2O. So, since we have two H's, we can say H2. There's two hydrogens. We need to multiply 2 times the molar mass of the hydrogen, and then add it to the molar mass of oxygen. So, that's going to be 2 times 1 gram per mole plus about 15.999. So we would get 18.0125 grams per mole if we wanted to do the molar mass of water. And now all we're doing is taking our numbers, our atomic weights, and adding them up. Alright, let's do some more, let's do some together. What about CO2? We have carbon and we have oxygen. So our carbon is going to be 12. We can round this to 12, and then we need 2 oxygen. So 12 plus 2 times 16. 12 plus 2 times 16 is 44. So our molar mass is 44 grams per mole. If we wanted to use all of the numbers, it would look like this. What is the molar mass of calcium carbonate? So this one's a little bit tougher. We have a few more things to add up. So our calcium, we have one right here, is about 40. Then we'd add a carbon, which is 12. And then we need 3 oxygens. This little 3 says that we have only 3 oxygens. So we need to do 3 times 16. So 40 plus 12 plus 3 times 16 happens to be a perfect 100. So let's do this to calculate moles now. So what we're going to do is answer the question, how many grams are in 3 moles of calcium chloride? So the first thing we need to do is find our molar mass of calcium chloride, because our molar mass is our conversion unit. So calcium, again, we found down here is 40, and then chloride is 35, and we have 2 of them. So we did 2 times 35 to get 110 grams per mole. And then now we need to convert. So if we want to go from moles to grams, we take 3 moles, and then we put moles on the bottom to get them to cancel, multiply it by 110 grams, so that 3 moles is actually 330 grams of calcium chloride. So let's do another one. We're going to write this one down. So what about the amount of grams in 2 moles of, this is acetone, but is the fancy word to say this. So we're going to find the molar mass of acetone. So we're going to need 3 times however much carbon weighs, so 3 times 12, 8 times how much hydrogen weighs, which is 1, and then plus 16. So this ends up being 60 grams per mole, and then we just get to convert it. So 2 moles of acetone, we're going to put our moles on the bottom so they cancel, is 60 grams, so we get 120 grams of acetone. So that is the introduction. We're going to do a lot of examples on how to use moles and the importance of being able to convert using our molar mass. We're going to practice finding molar mass more and more, just to make sure we have it down very well. So if you guys have any questions, as always, please let me know.